The idea behind an equilibrium price in Chapter 14 was that such a price would equilibrate demand and supply. In other words, at that price, the quantity demanded is equal to the quantity supplied. We'll now develop a similar concept of an equilibrium price for an Edgeworth box. In Chapter 3, we learned how budgets arise from endowments and prices. If I begin with an endowment of 3 oranges and 6 bananas, that endowment bundle will always lie on any budget line that we draw, and the slope of the budget line will be determined by the price at which oranges and bananas are traded. Suppose that they're traded 1 for 1, making the slope equal to -1. Then we get the budget line illustrated here. Unless my original endowment bundle is also my optimal bundle on this budget line, I will end up becoming a net supplier of one good and a net demander of another good as I choose a different bundle on the budget line. If, for instance, I optimally choose bundle A, then I'm giving up 3 bananas and getting 3 oranges. So I'm becoming a net demander of 3 oranges and a net supplier of 3 bananas. My wife's budget line will similarly pass through her endowment bundle, and if she faces the same prices at which oranges and bananas are traded 1 for 1, her budget constraint will have the same slope as mine. By choosing a new bundle along that budget line, she too becomes a net demander of one good and a net supplier of the other. If, for instance, she chooses bundle B, then she will become a net demander of bananas, because she would like to trade from 4 to 9 bananas, and a net supplier of oranges, because she's willing to go from 10 to 5 oranges. Combining panels A and B in such a way as to move the endowment bundles on top of one another then creates the Edgeworth box. Within that Edgeworth box, the 2 budgets overlap on the same line, a line that passes through the endowment allocation and on which both my wife and I optimize. The only difference is that I optimize by moving to the northeast, and my wife optimizes by moving to the southwest. But notice that at the price that has been proposed, my wife and I do not agree on which allocation within the Edgeworth box to move to. I'd like to move to point A, and she'd like to move to point B. This is what characterizes a disequilibrium in the Edgeworth box, and the disequilibrium arises from the fact that demand is not equal to supply. To see this, we can simply note that at the current prices, I'm willing to supply 3 bananas, but my wife is demanding 5. And I'm demanding 3 oranges, but my wife is supplying 5. We therefore have an excess supply of oranges and an excess demand of bananas. Prices in the Edgeworth box therefore determine the slope of the budgets that my wife and I are facing, budgets that will pass through the endowment allocation. And any time my wife and I would like to optimize at different points within the Edgeworth box, we will be at a disequilibrium price where demand is not equal to supply. The only way we end up with an equilibrium price is if we end up agreeing on the point within the Edgeworth box on which to optimize. This is illustrated in the next graph, graph 16.6.